In this video, we're going to look at how to export a model from Blender into the next 3D engine. To do that, I'm going to demonstrate exporting the cube model, which can be found in the Next 3D Models folder, cube.blend. There we go. So I'm going to open that. As we can see, it looks pretty much like it does on the Next. All of the colours are there. It is definitely a cube. It's centered on the origin, so you can see the origin lines going there and there, and presumably there's one going up and down as well. All of the points are centered around 0, 0, 0, which is in the middle of the cube. That's because I want it to rotate around its own center. There are a few things that we need to consider with regards to the models before we export them. The first is how to build the model. I'm going to switch it to wireframe view. There we go. That's up here. That one there, viewport shading wireframe. You can see the model's actually built up out of triangles, so each square face on the cube is 2 triangles. So the entire cube comprises of 6 faces, each built up out of 2 triangles. So that's 12 triangle faces, if that makes sense. That's pretty straightforward. If you need to build up more complicated shapes, you can build them up out of triangle meshes. Cube's probably a really simple example. Have a look at the Cobra model for a more complicated example of building a shape, in that case a spaceship out of a triangle mesh. The next thing we need to consider is normals. Now, normals are invisible lines that determine the face orientation. In this shape, all of the normals are pointing out towards the viewer, not in towards the inside of the cube. Normals are important. They're used for things like backface culling, so hidden face and line removal, and light sourcing, so illuminating a face according to the angle of the normal against the angle of the light source. So how do we determine whether or not a face's normal is facing out or in Blender? Well, it's actually quite straightforward. If we go into the overlays menu up here, in the geometry section, there's something called face orientation here we need to check. So if I check on that, leaving the view in wireframe view and disabling X-ray, which was on for some inexplicable reason, so I've just got the wireframe shading on here, you can see the cube's now turned blue. Now, blue means that face is facing outwards, not inwards. If it was shaded red, that would mean that that face is facing inwards rather than outwards. So I'm going to demonstrate how to flip faces that are facing the wrong direction. Now, you do that by making sure that you're in edit mode and object mode up here. You can select a face, so I've selected this face here by clicking on it. Go to mesh and then normal, flip. So you can see now that that's changed red. I'm going to do the same for another one up here. So mesh, normal, flip. Right, so this is now a cube that is not correct. If this was rendered in the Next 3D engine, this face here would be visible when it shouldn't be visible, and vice versa. There's a shortcut as well on the Mac. It's Option N for normal. So it pulls up a context menu. Click on there, Option N, flip, Option N, flip. So now the cube is correct. All of the faces are blue. That means all of the normals are correct. They're all facing outwards, which means that this cube, when rendered in the next 3D engine, will display the faces at the appropriate time, which is good. For this next bit, we can switch off the face orientation overlay we set earlier by clicking on overlays and then unchecking face orientation. And we're going to switch from wireframe mode to solid mode by selecting viewport shading solid here, which is next to the wireframe option. The next consideration is the face colour. It would be really helpful if I could just draw my shape in Blender, assign all of the faces a colour, and for that to be somehow imported into the next, and for it to understand that for a given face, say this blue one here, it needs to colour it in the next 3D engine in blue picked from the next colour palette. I don't think there's a simple way to do this, but I've got a kind of a bodge way which works for me. So what I've done is I've set up a load of materials here in the scene, red through to white. There's 7 in total, the primary colours for the cube. And I can assign each one of these faces a colour from that material, of that material. So say, for example, I wanted to change this face from magenta to white. I make sure I'm in edit mode. I select the face. It's currently set to magenta. If I change it to white by clicking on the material and assign, you can see that it changes to white. So there we go. So my cube's now got a white face rather than a magenta face. But how do I create new materials? Well, I can just click on plus here, add a material slot. I'm going to create one called brown. So click on new, give it a couple of seconds to think about it. I'm going to name my material brown. There we go. And in the properties, I am going to click on viewport display, set the colour here, pick a brownish colour. Oh, there we go, straight away. I'm going to copy that value. I might need that in a minute. And there we go. That's set to brown. And the surface colour, the base colour set to white. I'm going to also set that to brown. So the previously copied hex value I'm going to paste into here. So that's also brown. So the brown material's got a surface colour of brown and a viewport display of brown. So now I can change this face to brown, like so. Select the face, brown, assign. So there we go. I've changed the face from magenta to white and then created a new material, brown, and assigned it to that. So how do we export our model in a format that can be used by the next 3D engine? Well, the first thing we need to do is export it into an intermediary format. And for that, we're going to use the Wavefront format, which is a plain text file. So we're going to click on File, Export, Wavefront. It'll pop up a dialog with some Wavefront specific options on the right hand side. The key ones that we're going to check are normals, colours and materials. Everything else uncheck, and leave the top as what I believe are the Blender defaults. So scale of 1, forward axis of -Z and up axis Y. Then we're going to export that, and that will create 2 files. So let's have a quick look at the files. The first one, which we're going to largely ignore, but it's worth looking at just out of curiosity, is a .mtl file. This contains information on the materials that we've defined here. I have no idea what these values mean. I've not looked into it. But you can see it's added the brown one that I created during this tutorial here, and we've got all of the other ones listed. So we can ignore that for the time being. I don't use that at the moment, may use it in future, not got any plans to. But the file of importance is the .obj file, so let's have a look at that. Again, it's a text file, so we can open it in text editor or notepad or the plain text editor of your choice. And you can see that we've got some vertice information. There are 8 vertices corresponding to the corners of my model. In this case it's a cube, so it's fairly straightforward. We've got 6 normals. I'll explain why we've got 6 and not 12, one per face, in a minute. And then we've got some face information. And each cube face is comprised of 2 blender faces. So if I scroll this round to red, you can see that as we step through this list, for this particular face we're going to use the material red. The name's actually important, that's the bit I pick up in the Python script. And then it's got 2 faces, which has got 3 pieces of information, each one containing 2 numbers separated by a double slash. So if we look at the first numbers 2, 6 and 5, that tells us for this face which vertices to basically join the dots. So this face is comprised of vertices 2, 6 and 5, and the second digit in each of these triplets is the normal to use. And the reason why there are less normals than faces is because these 2 faces share the same normal, which is basically normal 5, which is this one here. And then it's rinse, lava and repeat for the other faces. So green is joining these dots together, 2, 3 and 7, which is 2, 3 and 7, using normal 1, and then 2, 7 and 6, so that's 2, 7 and 6, and so on and so forth for the other faces. So this is the intermediary file that is used by my Python script, which will convert this into something that's a little bit more palatable for the next. And we're going to have a look at that right now. So let's have a look at the Python script I've written. There are a couple of things to note. The first is I have this list here, which is currently hard-coded to what I believe is the default layer 2 palette. So for each of the materials named in the obj file, I have a corresponding lookup number, so a number between 0 and 255, or 0x00 and 0xff. I've not got brown in here at the moment, so if I was to import the cube model that we created earlier, I'd have to add a brown entry in here with a corresponding lookup to a brown colour in the next palette. So that's basically how we translate colours from Blender to colours on the next. We maintain this table here. The script itself takes 2 parameters when you call it. The first parameter is the file name, and then the second parameter is the scale. If you omit the second parameter, it defaults to 100. Now, there's currently a limitation on the Next 3D engine where models cannot exceed about 120. Because it's stored as 8-bit maths. So I do a little bit of a check to make sure that the coordinate data is out of range. Here we set it to minus 128 or 127. So if we exceed the 8-bit 2's complement value in any particular coordinate, then we just basically throw an error during the convert stage. So the script itself is fairly straightforward. It will tell you if there are any errors with the input data, the .obj file. And what it does is it converts the obj file into a .h file, which can then be included in the Next 3D engine and then used as a model. So there are some examples in models. So let's have a look at cube.obj, which was the one we looked at earlier. There we go. That's the input file. And then cube.h, you can see it's basically converted it into something that uses the structures in the next 3D engine. So we've got a top level object here, which describes how many vertices and how many faces there are, so 8 and 12, and then a pointer to the vertice data, and then a pointer to the face data. I really need to change those labels to vertice and face rather than point and vertice, because it's a little bit confusing. My reasoning behind that is a list of vertices rather than the face. Up for debate whether or not that's right or wrong. I might come back to that. So that's basically how you export a model into the next 3D engine. How do we use it? So let's have a look at the cube demo, just to give us a rough idea of what's involved. And you can see that all I'm doing here is including that H file that's been created by my Python script into the source. And then later on, I'm not going to go into too much details here, I'm setting up an object. So that's basically an array of object 3D types, and in the model parameter of that object, I'm just pointing it to the cube model here, which corresponds to I can find the model directory, cube.h. Let's just lock that in place so I can flip between it to this top level object, which has been created by the Python script. And I'm going to go into this in a little bit more detail at some point in another video. There are some other parameters in here which tells us where to render this model in the world, and its rotation values, and the subroutine that we want in order to move this particular object. In this case, I've got a function called rotate, which just spins the cube around. You can see here I'm just altering the angles. Flags I'm setting to 1 at the moment. That just indicates that this object is active. And then if we scroll down to the movement routine, I just iterate through the list of objects. Well, I've only got one active one. If the flag is 1, i.e. it's active, then I draw the object. Render mode is a flag which determines whether or not to render it wireframe or solid. And then once I've drawn it, I move it. And then there's some preamble at the top and the bottom to clear the off-screen buffer. And here, waiting for a vertical blank interrupt so it's smooth. And then here, I'm swapping in the buffer that we've drawn into here onto the active screen. And finally, let's have a look at how that looks in an emulator. And I am going to use CSpect. There we go. So these are the parameters that I use in CSpect in order to run the demos. So CSpect needs to run in mono. I'm doing it on a Mac. It's a bit the same for Linux. I think for Windows it may be different. I'm not sure. You might just be able to run CSpect.exe in order to make it work. And then passing various parameters to initialize the emulator. And then at the end, these seem to work for me. A path to the .next file, which we've compiled in Z88DK, and hopefully, I think I need to flip this in once it's started. That's running. There we go. Oh, sometimes it does that when you move. There we go. That's our spinning cube. From Blender to emulator. And of course now we could run this on actual hardware. And there we go. Hopefully that will give you a bit of an idea about what's involved in getting model data from Blender into the Spectrum Next 3D engine I'm developing. It's all very much a work in progress, the 3D engine, and this process may evolve over time, but at the moment, that's that. If it does change the process, then I'll provide an update in the form of documentation or an update to this video. I'm sure I'll probably get a lot of people saying, that guy really doesn't know how to use Blender. Well, that's true. Up until starting the Next 3D engine, I'd never touched it before. I'd heard of it, never touched it. And I'm not an artist by nature. I've never done modelling before. I learned just enough in order to get the job done. But hopefully you can see that despite it being a very intimidating and thorough package, you only need to know a small amount of its functionality, in my case a fraction of 1%, in order to get the job done. And hopefully this guide will give you an idea about which menu settings in order to check in order to do so. Yeah, so that's that. Hopefully this video will be of use to you, and I will see you in the next one.